Hi guys, today we're going to talk about data wrangling. Let's start with the definition. Here's a definition from Wikipedia. Data wrangling, sometimes referred to as data munging, is the process of transforming and mapping data from one raw data form into another format with the intent of making it more appropriate and valuable for a variety of downstream purposes such as analytics. A data wrangler is a person who performs these transformation operations. Well, if you followed that description, you might realize that really what we're talking about when we talk about data wrangling is basically the same thing as the ETL process. If you look and see, you see that they're talking about taking data from one form and transforming it and then into a more appropriate form so that it will be more valuable for some analytics to be done in the future. And then, of course, it would be saved in a new format. And then that new format could be used for creating models or doing some advanced analytics. So ETL process and data wrangling basically is the same thing. Now, really, we've done a lot of this already. When we were talking about NIME, we learned how to do a lot of different kinds of transformations. We learned how to aggregate and how to just change some columns around and do some data cleaning. We specifically have talked about some of that having to do with using Python and pandas, but one thing that we haven't talked about yet using Python and pandas is cleaning our data. So today our focus will be on cleaning our data using Python with pandas. So why clean our data? Well, it's sometimes not really that important to have a clean data set. If we are just looking at data in general and there's some columns that have some missing data or some invalid data, if those are columns that we don't care about anyway, and maybe they're going to not even make it into the final form of our data, then it's really not that big of a deal. We don't have to clean that. But if we have some missing data or some invalid values and they occur in some important columns, some columns where that we're going to be using to make predictions, then we really need to make sure that we have some clean data. So that's why we need to learn how to do it. So here's some different problems that could occur when we are given just some data that might not necessarily be in a really useful form. We might have some missing values. So we might have some nulls on some of the different, in some of the different columns on some of the different rows. We might have wrong or inconsistent formats, inconsistent categorical values, or we might have outliers or invalid values. Now, this might seem a bit familiar because we've been through this whole discussion back when we were learning how to clean data in NIME. So really, this is basically a duplicate of the discussion that we had back then, except that we'll be learning how to take care of this in Python with pandas instead of in NIME as you did before. So we're going to be using the same mock data file that we used back when we were first learning how to clean data using NIME. I used the website called Mockaroo to create some mock data, and so it's the data mockdata.csv, and that will be posted on Canvas. So if you want to pull that down and go along with me, you can pause this recording at any point and perform those operations within Spider if you would like. I'm not going to actually show me working within Spider here today. I'm just going to go over the different commands, and you can then use them if you'd like. Your lab, you will have a lab that I will assign here at the end of the video, and you'll be doing these kinds of things. You'll be typing these commands into Spider. So if you're following along with me, then go ahead and open Spider. And if we're going to use pandas, remember the first thing we need to do is to type import pandas as PD. That's saying that we're going to use that library called pandas, and it's also saying that we don't want to type out the full word pandas from here on out, so that's why we say as PD. That way we can just say PD whenever we're wanting to refer to pandas. So first of all, we'll read in our data. So we'll read in using the read CSV method. Now, this is some data that is not necessarily going to be clean. I've created it to be messy, in fact. So first of all, if we were to look through it, we might see that there are different genders in there, and we might want to see what are the different types of genders. And so if we type DF, and we've remember in the statement above, we had when we read in the CSV file, we saved what we read in into a data frame that we're calling DF. So now this next line is saying, let's look at the gender column in DF and find out how many of each type shows up. We see that there are 161 values that are called female, 125 male, and there's 5 that are female with a lowercase f. Then there are 5 capital M's, 2 capital F's, 1 male with a small capital M, and another capital F that we'll have to figure out here in a little bit why this capital F shows up twice. Another thing that we can do to see, and so basically, I guess before we go on, I should say that we see some problems here because we have our gender being represented in lots of different ways, and so we need to consolidate that and make sure there's only one way that we define as a record as this data being a person who's female, and one way to designate that they're male. Okay, on to the next one. Here we're checking to see the values for ages. We can see, if we see a bunch of ages, we can say, wonder if there'd be any invalid values there. So what we might want to do then is find the maximum age. So here you see the statement that we can use for that. If we type that in, don't type in the 166, but the 166 is what will come back as the maximum of the age. So we see that's a problem because we know no one is 166 years old, assuming we're talking about people, which we are in this case. We can also check the minimum, and we see a minimum of -12. We know that cannot be an age, so we see that there are some invalid values for age. Another thing we can do is check to see how many null values there are. So first of all, if you look at this, first look inside the parentheses first, after the word sum. You see that we're taking the column labeled age and looking through each of those and determining if there's a null value for each record. So then when we put all of that into this sum with the parentheses, we're saying how many add up. If it's null, it's going to come up as 1. The isNull method returns a value of 1. If it's not null, that method returns a value of 0. So when we sum all of that up, it would basically be adding up the number of null values for age. So we see that there are 25 null values for age. And we could do the same thing for any other month, any other column. So here we did it for birthday month, and we found that there's 43 null values for birthday month. So we see that this data has some problems, and we're going to talk about different ways that we might be able to clean this up. Okay, missing values. Let's start with that. So when we have missing values, we want to decide, first of all, how, again, we kind of talked earlier, but let's talk again about how you would find out if you have some missing values. So here you see this sum statement again. Inside you see the blue is where we're just going through whatever our column is that we're wanting to work with. And we would go through that column, check to find out if each value is null or not, and then add all of those up. So if we put that blue part inside this sum method, then we find that we are getting the adding up how many values are null in that particular column. So what happens when we find that some are null? What are our solutions? And we kind of talked about this before when we were working with 9. One of these solutions is we could drop some or all of the rows with missing data. So if there's a row that has some missing data, we could decide to just drop the entire row. And maybe if we have lots and lots and lots of data and not that many rows in comparison with missing data, we might say, yeah, we just don't even feel like this row is even significant. We don't even need it. So we could just, drop the entire row. So here's how we would drop if we aren't even looking at any specific columns, but just saying, let's just look through any rows with any missing data. Let's just drop the entire row. We would do this. We say df equals df dot drop NA. Now remember what this does. The equal sign is an assignment operator. So whatever is on the right side gets assigned to whatever is named on the left side. So on the right side, we're dropping all of the rows that have any missing data and getting a new data frame, and then that new data frame will be put into df. So df gets changed right there, and all of the rows with any missing data would be dropped. But maybe we don't want that to happen with just any row, but maybe any row that has more than 6 nulls. So looking at all the different columns, maybe there's 6 columns or more with nulls, we might decide, yeah, this is pretty useless. Let's go ahead and drop. So this is another way. If you don't want to drop all rows with any missing data, you could do this and just set the threshold to whatever you want to. So you could set the threshold to 10 or more if you really wanted to. Another thing that you could do is, if you're only interested in certain columns and you really don't care if maybe the email column has null values, because maybe you're not going to use the email column in anything, but you've got some other columns that are very important that you're going to be using in your analysis, and you don't want to use data that's incomplete for those particular values. So you could say, inside that df.dropNA, you could say subset equals, and then put the column name. And then that will just drop rows that have nulls for that particular column. So here's an example in our example database data set that we're looking at. If we type in this sum df age dot is null, we find that there are 25 values, and then the question would be, what do we want to do about it? Now, all of these solutions, and we're going to come up with some more solutions here in a minute, but all of these solutions are just possibilities, and you just kind of have to use your own judgment with the data that you're working with the situation that you're in, to determine what you want to do. So one person might do one thing, another person might do another thing. It's not a problem if you do something differently than somebody else. You just want to try to use your common sense and do what you consider is best in that situation. Okay, if you don't want to drop entire rows, maybe you want to drop entire columns that have missing data. So again, maybe it's a column like email that you don't even care about anyway. So that's something else you can do. So you can still use this drop NA, but if you put access equals 1, what happens is that it starts looking at it as dropping columns and not dropping rows. So access equals 1 will make this drop columns, and then the how will tell you, how do we want to go about this. If you say how equals any, then it's going to drop all columns that have any null values at all. So any column that has any nulls, it would drop. That might not necessarily be what you want to do, because maybe you have a column in there with some null values that is the column that you're most interested in. So you have to be careful on that one. But here's one where it's going to drop all columns that have all null values. So if there's a column that has nothing in there for any row, everything is null. Well, it definitely makes sense that we probably don't even want that. So this might be something you want to do. Just drop, if you say how equals all, then it'll drop any columns that have all of the values are null. Okay, and here's one where instead of drop NA, we're just saying drop. And then we also see that we list column names. So here in the square brackets, I have column name, and you would replace that with whatever the column name is. And then a comma, and then I have another string in there saying keep listing other column names. I'm just trying to show that you could list 5 different column names in there if you want to. So just to list all of the different names of the columns, one right after the other with a comma in between. You put that list inside the square brackets, and then say comma access equals 1, and it will drop any columns that you name in there. So that way you can drop more than one column at a time. And that's not, it's not going to look and see which are null and which are not, because you're just specifically naming the columns. So it's just going to drop those columns whether or not there's any null values in there or not. Okay, and a third option is we could replace missing values with the mean of their column. So for instance, here you see that we are on the right side of this equal sign, we have df.age.fillNA, and then inside those parentheses we have df.age.mean. So what it's doing is, first of all, look inside this innermost inside the parentheses, the df.age.mean. It's going to find the mean of the age, and then it's going to take that value and fill in any place in that column age that has a null value. And then that's on the equal sign, that's on the right side of the equal sign. On the left side of the equal sign, it's saying that we're going to replace that column with this new column. Now, if you have a categorical value, you can't get a mean. Like, what's the mean of gender, or what's the mean of hair color? So if it's a categorical column, you might want to use the mode, which is the one that shows up more often. Let's go ahead and replace it with that. Okay, so those are the different ways that you can handle missing data. Now, what about wrong or inconsistent formats? So maybe you have some data that has inconsistent casing. So for the color red, you might have red just with a capital R, or all lowercase, or maybe everything will be uppercase. So you want to get them all the same so that they can be looked at as the same value. So one way, probably the easiest way to do this, is to just turn all of those, if this is color, then just turn everything in the column called color to uppercase. And so you can do that by just taking the column name and df column name, and then .str for string .upper, and it will take everything in that column and convert all of the characters to uppercase. And then again, that's on the right side of the equal sign, so whatever we get there gets put into the actual the column that we're working with. So we have a new column now, and then it would all be uppercase. Now sometimes we have white space, so we might have a space at the end of a value and of a string value, and we wouldn't. So we might have two values that are supposed to be the same, but they are being looked at by our programs as two different values because there's this white space that no one can even see, but it's there, and so that's why the computer sees them as two different ones. So anyway, we can just do this strip command to strip everything in that column to get rid of the white space. Another problem that we can have is that sometimes when we pull data in from a CSV file, we're wanting to look at a certain column, the values in a certain column as numbers, but they might, depending on how they got saved in the CSV file, they might pull in as strings. So for instance, you might have the age come in, and instead of 1, 2, 3, those numbers, it would be in quotes. So that means it would be looked at upon as not a number but a string. And the problem with that is if age comes in as a string, then the order is going to be different as from if we're ordering strings, it's different than ordering numbers, because in a string the number 2 would be looked at as bigger than 12. So because 2 starts with the character 2, which is bigger than the first character of the string number 12. So anyway, we would really want, if we want to treat things as numbers and be able to sort them correctly, we need to treat them as numbers instead. So here's a way that we can do it if we're pulling in, when we're first reading this CSV file, we could do this by just adding that extra D type part. So everything else you've done before, but just add D type and then put the column name and then what type you want it to be. So if it's an integer, then just say int, and then it will come into your pandas data frame as a integer instead of a string. And these other statements can work too. So here we could just take, after we've read everything in, so the one second ago, that was if you haven't read everything in, but if you've read everything in already and then realize that you need to change the type, you can just do this. So you say dot as type and put the type in. So in this case here, we would be changing the type to a string if we put str in the as type. But if we wanted to change it to int, we could put as type and then int, and it would turn it to an int. And here's another way to do it. Now, I just want to remind you, you don't have to memorize any of these statements. You're going to have your Python/pandas reference sheet. You'll be able to use it to work on your lab for this week. You'll also be able to have it during your test. So none of this is anything that you have to memorize, but you do want to be familiar with them and have a chance to practice them a lot so that when you have to do something on the test, it will be familiar to you. Inconsistent category names. So if we had a country column and sometimes maybe for United States we'd have US, sometimes United States, maybe even USA, well, we would have to decide which way do we really want it. And so if we decide that we want all of the United States values to be changed to USA, we would use this replace method. So we mention the column and then say dot replace, and then inside the square brackets we say what are, we list as many as we need, the different values that we want to get rid of, and then after that we have a comma, and then we put the actual value that you want to replace all of those with, and that will do the replacement. Now looking back and using this gender dot value counts, we see here are the different genders that are in our sample database data set that we're looking at here. And it looks like we've got a lot of different inconsistent category names. So what we'd want to do is do several things. Let's decide how we want this. Let's say that we want all genders to be either male with a capital M or female with a capital F. So we would see the problems and then change those. So capital M and then male with a small m, those need to be changed. So we would put those into the replace method and then say that we want to replace those with male with a capital M. Now we also see this problem here, two capital F's. They look exactly alike, and yet they show up, it shows up twice. It says there's two of one of those types and one of the other. This is a case where there's some white space after one of those, so it's looking at it as capital F space compared to just a capital F. So it sees it as two different values. So we need to change that. So if we strip everything in the gender column by using .str.strip, then we'll find that if we do this gender value counts again, no longer do we have those two capital F's. It's put them both together. So now that capital F space has turned into just a plain capital F because of that strip command. Then the last thing we would need to do, we still have a couple of female types that are in the wrong format, so we would change those into the female with a capital F, and then we should have only two types of genders in there, female and male, both capitalized. Okay, fixing invalid data. Well, first of all, we just kind of look and find suspect values and decide what we want to do. Usually it's easy enough to find the problem values because we would kind of decide what would be what would we consider as the upper bound for some values and what would we consider as the lower bound. So what we found, we had this column in our sample database data set called age. And we would just do a max command in order to see what's the highest age. And when we see, yeah, that's a problem, so we know that at least there's this one high value, but there might be others too. There might be some that are 110, 113 that we feel can't be correct. So we would have to be thinking what we might want to do about it. Also, we look at the minimums. And here for age, we see a -12. We know that can't be, so we know we want to do something. So what do we want to do? Well, if age is something that we are really caring about in our analysis, then, you might want to just delete the entire row. Say, this row is not helpful. We're not going to get anything useful out of it, so we might want to delete the row. And if we did that, we could do this, where we're replacing the entire data frame with a new data frame that has only age values less than 102. That would just, maybe you would want to take it up to 105 or something, but this is just an example what I did. So inside those square brackets, that's just the condition. Only rows where this condition is true will now be part of this new data frame, and then we're going to set that equal to DF, so DF now is our new data frame with only ages less than 102. Or we could replace with the mean. How would we do that? We would use this. So we're saying on the right side of the equal sign, we're finding the mean of the age column. And on the left side, we're saying, okay, this is what's going to get replaced by our new mean, by the mean that's on the right. It's going to be any values in the age column that happen to be greater than 101. If they're greater than 101, that's the condition, then they get replaced by the mean.